بسم الله الرحمن الرحيم. ربي اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقهوا قولي. Today I will present one of the basic topic that relates to the evaluation of payment, and that is related to a runway apron or taxiway payment, or in other words, I will discuss how to evaluate the strength of an airport pavement, and uh, this is a latest technique that is called PCR method, pavement condition rating, and how to calculate it is the sole example of today's lecture. And most of you know, my name is Adnan Kadir and I belong to NID University. So let's start. For instance, uh, I have to solve this problem. Obviously, this problem is very hypothetical, in which I have to apply ICAO ACR PCR procedure of FAA AC 150 oblique 53355D, and we have to find PCR value of runway using the data given. Two types of data that is needed to be known. One is the type of pavement. So it's a rigid pavement having a PCC thickness of 400 mm. Crush aggregate base course is 300 mm and its subgrade strength is 75 mega Newton oblique meter cube. And then there's an aircraft data. Uh, Six types of aircraft having the given gross weight, annual departure, and its percentage annual growth. So let's try to understand what are the basic ACR PCR definition. There is an aircraft classification rating. That means a pave number that expresses the relative effect of an aircraft at a given configuration on a pavement structure or a specified standard subgrade strength. This is pavement classification rating. Some also call them as pavement condition rating. A number that expresses the load carrying capacity of a pavement for unrestricted operation. Now, what is the system that the ACR PCR system is structured so a pavement with a particular PCR value can support an aircraft that has an ACR value equal to or less than the pavement PCR. And this is possible because ACR and PCR values are computed using the same technical base. So what is the background? Every runway pavement have been obviously designed in its time and with multiple revolutions, multiple innovations in aircraft manufacture. There are aircraft like Airbus 380 that has got a larger size, larger passenger carrying capacity. So if, and they are now in in the industry and is been operated by different aircraft, different uh, different uh, aircraft aircraft operators. And what we need as a design manager is to see whether the aircraft that is being landed is will not going to will not going to damage our pavement or not. Every aircraft manufacturer has calculated their own uh, requirement, and this method of PCR actually uh, gives us the way to check the existing pavement. Now, for an aircraft that is being allowed to land in a particular area must have an ACR less than the PCR. And if it is not, then at the end of this lecture, towards the end of this lecture, I will discuss how uh, this can be accommodated. So let's go with the with further is uh, how this ACR PCR will be implemented is the release of ACR established as the new FAA standard for reporting airport pavement strength. Uh, and they say by September 2024, all certified airports shall report PCR in their manual. So at this time, the FAA has complied with the implementation of ICAO or ICAO as a new standard practice for the United States for reporting pavement strength. So how this PCR is required for pavement management? The structure evaluation, the pavement focus on remaining live and not the pavement. Since PCR can be developed at same time, since it uses the same data, using typically a PCR will use material strength that are computed through non-destructive testing, and the traffic should be at least 20-year projection, not the remaining design life. Typical structure is 8 to 10 years. It is not logical to develop PCR for all pavement. Runway pavement must be reported on all pavement. Taxiway should be assessed based on usage and previous projected traffic. And appearance should be assessed based on aircraft that can access the pavement and usage. Now, how the given problem is solved is very easy. What you can do first, you have to actually FA has also introduced a software, and that software uh, was previously used to design a new or regulated pavement. But in the latest version, this far-field tool has been introduced that not only calculate the new strength, but is always now has an option to calculate, to click that option to calculate PCR of the pavement. And in a little while, we'll know how to use this software. So let's continue. So the first step, what you do when you open this face file, you have to write the job information. And in the job information, you have to go for the design option as well. Since in this given example, we are using matrix units, so all you need to do is to, select this metric options. You have to write the job name. You can have a different section of the pavement, section of the runway. You can write it that like this, and you can always change it to the PCR value. Now, let's see what is the second step. Once you change the unit, the second step is to input the material properties. For material properties, you go to this FAR and allow me to go to the material option, and you will have, say, write a new job. For a new job, you can have different material, and if you select a new job, so first you have to write a new job. You have selected one, and then for new job, you write, say, YouTube, my YouTube. Uh, I can name it like this, say YouTube. And then I will say it's a rigid pavement. So a new rigid. Now this is the section that is open to me. So what I need to do is I now need that not need these options. So I will know, just those of you who know how to design, use far fill. This is nothing. So here I will type, say, because actually what happened for this thing, I have not selected that matrix unit. So let's go back and have a new job. And then I have a design options. So what we can do is when I do this thing, I have this window open in which I have a PCC surface, 400 mm. Then I have a crush aggregate hose. I will put here. Here I will have to write the modulus of rupture, that is 4.48 megapascal. And I have to type my K value that I have given 75. So that will automatically be calculated. So step 2 is about the material information. And then in the step 3, I will go the same. I will select the aircraft option and will start inputting the aircraft. So let me show you how in the software we do that. So what happened is that, so I have a new section and I have a new job. It is YouTube. YouTube, and have a thickness design. Then I will go to the Explorer. But for that, because I have not selected the unit, so select the unit over. This is metric unit. This is okay now. And then I will design a new section. I will select this pavement type. This is a new rigid. So here I can type this thickness is 400 mm. That was, and then I will say uh, this, I don't need this layer, so I will say the second layer I don't require, so I'm going to delete it, this layer, second layer, by clicking on it, and I don't need this layer, so I'll say I'm going to delete this layer, right? Now the second layer, this is crush aggregate base course, and I'll say this is 300 mm. So that's okay. And the first layer was my 400 mm. So I'll say that this is 400 mm. And that's okay. Okay. And let's see. I will say this is a new, and we'll say not PCR first. So we'll say this thing. I can write this. So once I done this, I will now go to the aircraft data. And from aircraft data, for example, I need to select SWL. Once I'm going to click it, I'm to enter the gross weight. I will going to take the annual departure, and I will take the annual growth rate and the total departure. That's it. So to summarize this, I have done this already to save my time and your time. And I will put all those data that is being given here. Once I've done this, I will select this PCR as I know because my objective was to calculate PCR. Once I do that, I will run that, and at the end of this, I will get the PCR value as 530 oblique R oblique A oblique W and WT. So this is what is my pavement PCR, that is for the pavement that I have analyzed. Once I know that, now it's a time to know the results. And from here, if I go to the Explorer, I have to select this Explorer, and then I will have different reports, the structural report, the PCR report, the PCR graph, the airport record, the structure. So first I will go for this PCR report, and this I'm getting that this is the analysis, and the PCR values comes out to be 526. Those of you who are in the field, they know we are, upload, we ground that to 530. Then thereafter, we'll also have a PCR graph. That's that's very important, and that's very important. The interpretation is easy. Now we can see that our PCR value is 526. All the aircraft except SWL-50 have the their ACR value less than the determined PCR value except SWL-50. And if I go to this airport master record, I will again know the value that this is 530 oblique R oblique A oblique W oblique T. And what does it actually mean? 530 represents the strength of the pavement in terms of PCR. R means the pavement type was rigid. A means the subgrade strength, that is higher, more than 150 megapascal. W is the tire pressure. So this pavement can sustain any tire pressure. And T is the technical. It means you have the actual data of an aircraft that is going to utilize this pavement. There can be U that is untechnical, and it is based on the experience. Obviously, far field always gives you this technical method. And if you have to have a type of aircraft, then you have to have a user-defined options in far field. So let's keep ourselves in the technical evaluation because normally all the type of data that are known to you as an airport pavement manager. Now, what does another value is the CDF value. That's very important. Those of you who know this far field method, they know the far field method determine CDF and there is interpretation of the CDF. CDF means cumulative damage factor. And if it is more than one, then that such loading is not allowed. Or it would mean that if it is allowed, it will damage and cause the pavement failure. So that's why you can see that in the PCR graph, it was for SWL50 has a problem. It has a higher ACR value, and this is supplemented by this CDF value as well. So what we are going to do? What is the interpretation? We say SW is not allowed since it has ACR value greater than PCR, but it can be allowed if this departure can be minimized, usage on the annual usage can be minimized, one, or the pavement should be have should be rehabilitated, means more structural layer should be added. This is the second way. And the third way is very simple. The other interpretation I've said, SCDF greater than 1, any operation of this type will damage the substrate. So that's, and how, and this is another, FAA has also specified how you are going to use in this data. That is what's called a master record. You can have a multiple runways, and for multiple runways, you have calculated the PCR or PCN previously. Now we'll have this value, and then we'll for each type of runway, for each runway, you can have 4 runways, 6 runways, whatever is that. You have to calculate the PCR value. So that's it. Thank you very much. You can always refer to my YouTube lecture. If you don't know how to calculate, uh, how to use far field, or you to know how to calculate PCN values, uh, you can also find it. Thank you very much. Take care.